Class. That was pretty weak. We're gonna have to try that again. Class. Much better. That was a whole lot better that second time. You had me worried there for a second, like y'all hadn't been in school for so long, you already forgot what to do. But I'm glad to see that you remembered. This is Mr. Lee. Hope you guys are doing well. Hope you are staying safe and healthy and not driving your parents crazy, being cooped up in the house all day. I'm out here in my backyard. I'm not like out in public, but I'm here in my backyard getting some fresh air, because you just gotta get some fresh air every once in a while. You can't stay inside all day, every day. And just because you're probably wondering, I'm in this little hammock chair thing, so I can like swing around. It's real comfortable, and I didn't create it. You might be wondering, all those weird inventions in your classroom and your contraptions, I didn't make this. Anyway, hopefully by now y'all have gotten your weekly work packet. Every week I'm gonna post up a video that's just gonna work through the packet a little bit. I'm not reading the whole thing. I'm not gonna go through every question, but just highlight a few key points and maybe work through a few questions. So throughout the video, you can pause it to work out little sections and then click play and pick back up. So here we go, let's get started. Okay, the first thing you're gonna need is your packet and a pencil or pen, something to write with. Maybe also a spare sheet of paper. So if you need to pause the video to get that, go ahead and do that. All right, I'm not sure how the physical packet, if you picked up a packet at the library or the community center, I don't know if it has page numbering, but to help us follow along in this video, I want you to label or number the pages of the science section. So on this first page, I'm gonna put S1, science page number 1, science page number 2. I'm scrolling through on a computer version, but you're just flipping pages and numbering them in your packet. Science page number 3, page 4, page 5, and page 6. Again, if you need to pause the video while you get caught up on that, go ahead and do that. The version I have that was on the computer, it looks like they have the exact same page printed twice. So you page 6, and then there's also a page 7 that's identical. So if you have two of the same page, cross out the second one. But if you only have one of this page, that's correct. Don't cross out this one page, number 6. All right, I'm gonna scroll back up to the top. So real quick before I start the video and go through this, I've got this little feature right here that's got like a little laser pointer, so I can kind of show you what I'm looking at. Sometimes I can switch it like this, where it looks like lava. It's like a little lava line, but then it's gonna disappear. So if you see me writing with this, don't try to write that down, because it's gonna disappear. It's just to point out what I'm reading. All right, so you can see that the topic for this week's packet is solids, liquids, and gases. So if I'm marking something in blue, or if it's not the lava line, you can go ahead and copy that down. So this is a topic you're familiar with. We've discussed it in class this year. You've also learned about this in previous grades. So this should be a pretty easy topic to start off with this first packet. All right, the states of matter. There's solid, liquid, and gas. They're the three main states of matter. So we're gonna go through each of those, and we have some facts. So solid facts. The molecules in solids are tightly packed together. They're squeezed in real tight, and it stays solid. Solids also can hold their own shape. They're gonna stay the same shape. An example of a solid would be a brick. All right, I'm gonna zoom in off to the side, but if you can write small enough, squeeze it on your packet. If you need a separate sheet of paper, that's fine, you can do it there. So I'm gonna do a quick sketch to help us remember the way the molecules are organized in a solid. So draw yourself a cube. To do that, you can draw a square, 3 diagonal lines, connect them. Now you got yourself a little block. So the molecules in a solid are tightly packed together. So how I'm gonna draw it, it's gonna look like an array. We have tightly organized rows and columns. Molecules are in real squeezed in, squished together, stay in the same shape. So the way you can remember that, there's a little trick to remember the way the molecules are organized. Solids starts with an S, and the molecules are squeezed, squished, and it's gonna stay the same shape. So a lot of the same sounds as alliteration. Solid, squeeze, squish, stay same shape. That's the way you can remember that. All right, so I'm gonna put this in like a little bubble to help keep it organized. That's the basic facts for a solid. Now to liquids. The molecules in liquids are not as close as those in solids, So they're a little bit close, but not as close as solids, and they have a little more room to move around. So if you think about liquids in real life, like you have a cup of water, you spill it, it's going to form a puddle and spread out. It won't stay stuck in the shape of the cup. Liquids take the shape of the container in which they are poured. An example would be water. Off to the side on a separate sheet of paper, let's draw a little cube to illustrate the liquid molecules. So liquids, they're a little more loose. So it's still a pretty good number of molecules, but I'm going to draw them where it's showing that they're not so organized, all tightly packed like a pattern and an array. Going to be more loose, so they could slip around. Excuse me. All right, the way you can remember that, liquids, they are loose, so it lets them move, like slip. That is not how you spell move. Okay, there we go. Ignore that. If I could delete it, I would, but it's not like that's how a cow. If you're imagining what would a cow say if they pronounce move, that's what it would have been. But really, this is how you spell move. Okay. It lets them move. All right, and the last state of matter is gas, and the molecules and gases are far apart, and gases can fill any room or any size container. That's why, like, if there's a gas leak in a building, you gotta figure out what's going on real quick and shut it down. Otherwise, everybody's got to get out because the gas can leak all over the building. Or if you think about helium as an example, in a balloon, if you go to the store and you want to inflate a balloon, they got this big gas tank they fill with helium, and it's going to spread out and inflate the balloon like a bubble, and it'll float. All right, to illustrate a gas off to the side here, there's our little cube, and the gas molecules, I'm going to draw a lot less. Let's just say 3, and I'm going to do like a little streak to show that they're moving. They're just zooming around every direction because they're filling up the entire space. It's not tight like a little pattern. So where you can remember that, gas, it's got a lot of gaps. There's a lot of empty space in between the molecules, so we could say it's got gaps. And they go all over. They're just going to spread apart real quick. Okay, so that's some highlights about the 3 main states of matter. The next page you have is talking about evaporation, and then boiling point, melting point, freezing point. We're not going to go over that right now, but you will have some questions on it, so you can come back and read through this section. All right, so we're going to look at just a couple questions to kind of work through them together, and that can have you, you'll be prepared to complete the packet by yourself. So number 3, number 4 we'll look at, and then we'll look at number 6 on page 4. So I'm going to zoom in to where we can see it better. All right, number 3. Use my little lava line here. The molecules, the line, here we go. The molecules and gases are close together, far apart, and moving. Separated just a little, but they're still, and they do not move. Molecules and gases. So that tells me I need to go back and look at my gas section of my notes. So the molecules and gases are far apart. That's exactly what the question is asking about. Molecules and gases are far apart. So once I went back to my text, now I'm ready to go answer that question with confidence, and I know I got it correct. Molecules and gases are close together, far apart and moving, separated just a little, still do not move. Obviously we know that they are far apart. So once you've gone through the notes and thought about what you're reading and kind of broken it down a little bit, pretty straightforward. Number 4, Elena tried to pull, push, poke the table, but the table still looked the same. Which statement can Elena write down in her science notebook after experimenting with the table? A, solids can hold their own shape. B, solids never hold their own shape. C, all solids have the same shape. Or D, a solid can fill up any container is put in. So I know I need to go back and refer to my solid section of my notes. Solid facts. Molecules and solid are tightly packed together. Solids also can hold their own shape. Okay, this is what the question was referring to. Solids can hold their own shape. So like if you have a brick and you drop it, it'll still be a brick. It's not going to spill out into a puddle. It's not going to start to float around and fill up like a balloon. It might chip, it might crack, but it'll be a solid brick. So number 4, solids can hold their own shape. We know its answer is letter A. All right, page 4. One last question, and then you'll be prepared to complete the packet. Number 6. Which is the process of a liquid becoming a solid? Okay, we didn't go over the section about this, but you can refer back to your notes. It's talking about the changes in a state of matter. So if you have page 4, again, I'm flipping back and forth real quick. If you need to pause the video, feel free. So over here, a liquid. So if I have like a liquid and it's turning into a solid, actually I'll draw that with it. It's not going to erase. So you got a liquid, like little water, like some waves turning into a solid. Just think about what you know from water and ice and water vapor or steam, how those change states. You have a liquid turn into a solid, and let's go look at our notes. Freezing point is the temperature when a liquid becomes or it turns into a solid. So that's the exact thing that this question is referring to. So that's freezing. When it's a liquid that turns into a solid, we know it froze. So freezing. All right, so you have some more questions to continue to work through on your own. Follow my little example here. Go back to the text. A lot of it's straight from the passage. And hopefully you guys will get everything correct on this first weekly work packet. You've had the packet you took home for the break, but now we're giving you a weekly packet. So keep that brain active and engaged until school comes back, whenever that might be.
Oh, man, this hammock is so comfortable I kind of dozed off. Hi, kids. You liked my video, didn't you? I know you liked the video, right? Just kidding, that's a joke. If you didn't get the joke, you need to go to Google and Google Dr. Binocs, like abbreviation for binoculars, Dr. Binocs, or search Peekaboo Kids. Watch about a dozen of those videos and you'll understand the, hi kids, you liked my video, didn't you?
So until next time, stay safe and stay healthy. And as always, don't forget to like and subscribe.